Hello, hello, hello. We are live on another stream. Session 41, studying for the GAMSAT. Welcome in, people, welcome in. Let me orientate myself here, get myself set up. I might. Oh, yeah, it's on. Gear. Bear with me for. Okay. Join the, if you're watching, wherever you're watching, join the join the Discord so you can you know sort out a study group or find out when I'm going to study live, and you can study live yourself, or you can just watch, or you know. I'm by no means a tutor or like a teacher or anything like that. I'm just a fellow GAMSAT taker who is interested in, getting a bunch of like-minded people together for a bit of motivation and a bit of ideas of what, talking about ideas about what each other's study looks like and the best study protocols and stuff that you guys have found. So if you're interested in that sort of thing, join the Discord or watch the videos that I post on YouTube, or stay on Twitch. Up to you guys. But get involved either way because it's all good fun. So today I'm going to start off with a little bit of skills building, like GAMSAT specific skills building, specifically maths, because I'm very weak in that area. And it's something that I don't mind doing. Like, it's not a chore for me to do, so I'll do a bit of that, and then I'll jump over and try and do some actual GAMSAT questions. No exam conditions or anything like that. Just trying to figure out use the skills to then train the reasoning process. Is the idea today? Is the idea behind today's session? So, with all that said, let's jump right in, hey? So we're doing the maths crash course. Should be fun. Who doesn't like a bit of maths?
In my opinion, maths is the most important skill for
Tell us,
Section 3 of the
James.
GAMSAT. In this course, you'll not only develop really strong mathematical processes to follow, but also hopefully a deeper understanding about the underlying maths, which I think is so important for the GAMSAT. I've structured this course into 3 sections, kind of going from the easiest stuff to the more difficult concepts, and each section really flows into the next.
Great.
I've also given you a maths ebook, which follows a very
Lovely.
similar structure to this course, and I really recommend going through both of them together. So watch the video and then go to the corresponding ebook chapter, flick through and really make sure you understand everything before doing those practice questions. They follow a very similar structure as I mentioned, so you should be able to follow along quite easily. The reason is because there's not that many quiz questions as part of the course. I've put a short quiz at the end of each chapter, but really if you want to practice these skills and
I
really
feel like
get
I
better,
forgot something.
the ebook's your place to go. Each video is equally
Oh, very good.
important, so really take your time to understand each concept well. If you do, I guarantee that you'll see a massive improvement in your maths performance.
Very good, James. Very good, very good. Oh, the bearded James. That's hilarious.
All right, so let's get started. So in this first one, we're going to start nice and easy. It's going to be going through some of those basic mathematical operations, as well as how we can rearrange equations. Okay, so I won't go into this too in depth because I'm sure a lot of you have an intuitive understanding of a lot of these things, but I will just kind of briefly go over these. So these are the basic mathematical operations. Now, basically, what I mean by operation is it's just something that is going to one of these little symbols, and it just tells you what to do with the numbers that are around it. So the first one is obviously an addition. So you might have something like 2 plus 2, and that just means you add those numbers together. So you can, count that out on your fingers. I'm sure we're all past this anyway. To equal 4. You could have a minus sign, which is kind of the opposite. So you're taking things away. So you might have 4 minus 3, and then that would equal 1. So again, they're kind of counting exercises. If they're not familiar, there's plenty of resources out there on the internet. I won't spend too much time on these. Multiplication is a little bit trickier, but it's kind of, in essence, it's basically a glorified addition, really. So I like to think of it like we have this many groups of this number. So for example, we have 2 groups of 3. So if I do 2 groups of 3, and if we think about it, that's kind of just like 3 plus 3, because we're just adding together all the groups that we have. So I like to think of multiplication kind of as a glorified addition. So that would equal 6. And then I kind of like to think of a divide by as a glorified minusing, just kind of in groups. So it's kind of just a way, rather than having to write out 2 plus 2 plus 2 plus 2, it's just a way to, organize it, or 2 minus 2 minus 2 minus 2. Just a way to organize it a bit cleaner. So we could have 6 divided by 3. And then that's basically saying how many times does this number go into that number. Now the order is really important with dividing. It has to be the second number. And how many times does 3 go into 6? So that would be 2, because it's basically saying how many times you add up 3 to get to the other number on the left. You also might see divide by written like this, which means exactly the same thing. And it just means that you have to have this. This is the second number that you're asking how many times does that go into the other number. So that should all be quite straightforward, but I do find that these more advanced ones, the powers and the square roots and stuff like that, that needs a little bit more explaining. So what we have here is this number in the box. Now I haven't put any number in there. This is called the base, and this number at the top is called the exponent. Now when we have a power operation, what it's saying is you are going to multiply the base, so the base multiplied, I'll just do the multiply symbol, by itself, the exponent number of times. Okay, so if we had something like, I'm running out of space a little bit, maybe I'll just move that down. So if we had something like 3 to the power of 2, this would be, so 3 is the base, 3 multiplied by itself, so 3 by 3 twice. So that would just be 3 by 3. It might have been a little bit confusing how I worded it with that twice, but basically it's how many times you need to multiply that number. So at the end of the day, you should have the base and then the exponent number of them and all of them multiplied together. This number doesn't have to be 2 as well. It could be something like 3 to the power of 4. So that would mean you have 3 times 3 times 3 times 3, because that's 4 times. So you can see how these numbers are going to get quite large, because 3 times 3 is 9, and then it's 9 times 3, which is 27, times 3 again, which I think is 81. So you can see how this number can get quite large quite quickly. Now the square root here, so now we're doing our last one, this square root sign here. This is the opposite of a power operation. So this is where it's saying, if we have a number, so if I have a number inside the bracket, so let's say 4, this is saying how many times, I like to think of mathematical operations as questions in a way. So how many, sorry, not how many times, what number multiplied by itself. Now I'm going to put a little invisible 2 here. I'm going to color code that by itself this many times gives this number. Okay, and we'll put that 4 in green there. So it's saying how many times do we need to multiply, or what number do we need to multiply by itself twice, aka the same thing as what we're doing here with the powers, to give me 4. So this would, in this case, this would be 2 times 2, because 2 multiplied, this is multiplying 2 by 2 twice. It's the best way I can word it, but basically just that many times you need to multiply it. And that will give you 4. Now, you don't often see these square roots written with that 2 in there. That's why I didn't have it in initially, because it's kind of implied. That's the most basic form. But you could have a cube root. So you could have a cube root here, and then maybe we put a 9 in there. Sorry, that's not a good number. We'll do 27. So this is now saying what number multiplied by itself 3 times will give us 27. So as we figured out here, that will actually be 3, because 3 times 3 is 9, times 3 again is 27. So just if it's a blank thing like that, there's kind of an implied 2 here, but you could have any number. So it could be a cube root or a root with a 4 in there or whatever. It's pretty unlikely, but basically it's good to know in case you might need to use a number higher than 2.
Okay, we learnt something. We learnt square roots.
So in simple terms, what algebra is are letters which represent numbers which can change. So if you could, for example, have many values.
I feel like, um, I feel like all this skill development stuff's good, but it's the actual implementation in the exam that's going to matter the most. So I'm thinking whether I add like once a week, because I'm like 3 months away from the exam, or we all are, 3, 4 months away. Where it's in, geez, when is it again? In November, is it? Yeah, November. Um, so what's that? What are we in now? Pretty much April, May, June, July, August. Wait, not in November, is it? Pretty much May, June, July, August. Not in November. It's in And then what are we in? April? No, we're in March. Oh, April, June, February, March, August, September. 5 months. Okay, 5 months. 5 months. 5 months. So we've got 5 months of study. It would be very amiss if I didn't in that time, once a week, maybe once a fortnight, once a week, once a fortnight, maybe once a fortnight. Um, do a full like practice exam for section 1, 2, 3 individually. Um, because without doing that, you don't really know if you're progressing or not. So I might add that to the study schedule. Once a fortnight, um, full section, full section practice like in exam conditions. That will go on the study list. And we're working towards something.
Use that could go into algebra is letters which represent numbers which can change. So if you had, if you could, for example, have many values that could go into an equation, you would represent that as a letter, and then depending on whatever number you have, you would just substitute that letter for the number once you know it. So it's basically like a placeholder number, but the number can change. So that's why you often see this called a variable, because it's a variable number. So an example of this would be something like y equals 2x. So we have a variable here called x, and this could represent anything. So maybe this represents your, let's just say your weight or something like this. And then y represents your height. So this will also be, and this is another variable because your height will vary if your weight varies. So this is kind of describe what this equation is doing is just trying to describe the relationship between height and weight. Now I've obviously simplified this, but there would be an equation out there such that if you multiply your weight by a certain number, maybe add on something, that should give you an approximation of your height. I imagine that's out there anyway. So that's the whole point of these things, and that's why we call them variables. However, we can often, so if we take this equation as an example, what this is saying is, just another thing I might point out. So we talked about multiplication. If you see something like this here, so 2x, so 2 and then a letter, there's kind of an implied multiply in here as well, okay? So you don't usually write it. You don't usually write something like 2 times x, but that's what that bit means there, okay? So what this is saying is 2 times your weight will give you your height. Now, if you think about that, that means, okay, if I double my weight, that will give me my height. But we could also say our height divided by 2 will give us our weight. So if we halve our height, that will give us our weight, because if we double our weight, that will give us our height. So what we often need to do in the GAMSAT, but just kind of algebra more generally, is we need to rearrange equations. So what we just did here was we rearranged this first equation for weight. So what I mean by rearrange it for is I want this variable on its own. I don't want anything else. I want to see what mathematical operations I need to do to the other variables to give me whatever variable I'm interested in. So that's why knowing these mathematical equations is important, because what you kind of need to do is be able to do the opposite mathematical operation. I like to think of it as moving that number to the other side. So if you take our first equation here, y equals 2 times x. Now, fundamentally, I hope that it makes sense that if you have to double your weight to get your height. If you halve your height, that will give you your weight. I hope that makes sense. So these two equations, you should be happy with that these are exactly the same thing. So how do we get from the first one to the second one? Well, what we do is we basically do the opposite as what's being applied to that variable. So I said before that what was happening to that variable is it's 2 times x. So if I have 2 times x and I could magically also divide it by 2, what happens is these cancel out, okay? Because we're multiplying by 2 and dividing by 2. And if we quickly go back to our operations, you'll remember that I kind of said that multiplication is like a glorified adding and dividing is a glorified minusing. And we know that addition and subtraction are opposites. So we know that multiplication and division are opposites, and they are. So if you double something and then halve it, you're back at square one. So that's kind of what we're thinking about here is we cancel them out. So if you do that on that side, then that means we cancel that 2 off. So I'm going to start again just so it's a little bit clearer. So we started with y equals 2x. Now it's 2 times x. And what we've done is now we've divided this by 2. So we're timesing by 2, dividing by 2, and that means these 2's will cancel out, and now that x is on its own. Now, the key thing is whatever you do to one side of the equation, you have to do exactly the same thing to the other side of the equation, because otherwise they won't equal each other anymore. So now we divide this side by 2 as well, and once all the kind of dust settles, we can see that x equals y divided by 2. And if I wanted to rearrange this back for y, I would just multiply both sides by 2. So now because I'm dividing by 2 and multiplying by 2, these things cancel out on this side. I need to do the same thing to the other side, and therefore I get 2x equals y. So I'm back where I started again. Just some other examples. So you might have y equals x plus 3. So if y equals x plus 3, then x will equal y minus 3. Because what I've done here is I've minus 3 from both sides. These ones cancel, and therefore I'm left with y minus 3. So all you need to do is find the operation that's happening.
I must admit, I slept through, from year 6 to year like 11, algebra and math. I'm ashamed to say this is useful.
And do the opposite. Another example could be y equals x squared. So remember, squared is I need to multiply that number that many times. And then the square root is the opposite of that. So if we take the square root of each side, this square root and that 2, the power of 2 will cancel out, and we get x equals the square root of y. Okay, so all of these, just get really familiar with all of those operations and know what's the opposite of each mathematical operation. So in simple terms, and we get x, this square root. If we take the square root of each side, this square root and that 2, the power of 2 will cancel out, and we get x equals the square root of y. Okay, so all of these, just get really familiar with all of those operations and know what's the opposite of each mathematical operation.
Um, what is it? So this
Groups of x out. So in simple terms, what algebra is, that this square root and that is the opposite of that. So square times, and then square do the opposite. Another example could be y equals x squared. So remember, squared is I need to multiply that number that many times. And then the square root is the opposite of that. So
the of there is the opposite of called exponentiation term. What is that? Okay, I'm a little bathroom break, and I should be back. I'll be back. need to make this, I'll save this actually. Nice, so I can use it again.
So if we take the square root of each side, okay, and the last little note that we'll need to make on this is to be very, very careful when you have something called, okay, and the last little note that we'll need to make on this is to be very, very careful when you have something called, well, what I like to call a complex equation. So what I mean by a complex equation is when you have multiple terms that are applied to this thing. So we have 2 times x and we also have a plus 3.
Order of operations. I think I know this. Isn't it like mum, dad, sister, or something? What is it? PEMDAS? What's PEMDAS? Plus, yeah, PEMDAS. Is that not it? Plus, minus, division. I don't know.
Now the order that you do these actually matters. So how I like to do it, and you just need to do a few of these and practice them. But if we divide this by 2, that's actually going to give us a different answer to if we minus it by 3. And the reason is this plus 3, it's actually 2 times x plus 3. It's not, but we could also have y equals 2 and then in brackets or something, x plus 3. So this is 2 times x plus 3. So what we really need to do is identify which thing is applied to multiple terms and get rid of that one first. So this one is 2x plus 3. So that means we need to deal with the plus 3 first. Whereas in this case, it's 2 times x plus 3, which is one term, so we need to get rid of the 2 first. So it's really just about, I even think it becomes quite clear when you verbalize it, which one's being applied to each thing. So in this case, we would minus 3 off both sides. And this is where you might need to do it in multiple steps. So we have y minus 3 equals 2x. And then we can divide by 2, which cancels that off. And that becomes 2. So it's y minus 3 divided by 2 equals x. And in this case, we would divide by 2 first because it's 2 times x plus 3. So then we have y divided by 2 equals x plus 3. And then we'd also now minus 3 from each side. So what we get at the end is y divided by 2 minus 3 equals x. So if you just kind of compare these two equations that I've got here, I'll just scribble that out. You can see how the answer is different depending on which operation you need to do first. So I'll put some practice questions in there, but I think what you want to really be focusing on is if it's a complex thing, it means there's multiple operations that are being applied to the variables. So you just need to think which operation is being applied to multiple things and then get rid of that one first. Okay. Equals 2. Get rid of the need to deal with. So this one, what we really need to do is identify which thing is applied to multiple terms and get rid of that one first. So this one is 2x plus 3. So that means we need to deal with the plus 3 first. Whereas in this case, it's 2 times x plus 3, which is one term. So we need to get rid of the 2 first. So it's really just about, I even think it becomes quite clear when you verbalize it, which one's being applied to each thing. So in this case, we would minus 3 off both sides. And this is where you might need to do it in multiple steps. So we have y minus 3 equals 2x. And then we can divide by 2, which cancels that off. And that becomes 2. So it's y minus 3 divided by 2 equals x. And in this case, we would divide by 2 first because it's 2 times x plus 3. So then we have y divided by 2 equals x plus 3. And then we'd also now minus 3 from each side. So what we get at the end is y divided by 2 minus 3 equals x. So if you just kind of compare these two equations that I've got here, I'll just scribble that out. You can see how the answer is different depending on which operation you need to do first. So I'll put some practice questions in there, but I think what you want to really be focusing on is if it's a complex thing, it means there's multiple operations that are being applied to the variables. So you just need to think which operation is being applied to multiple things and then get rid of that one first. Okay. Because these ones, although they look very similar, oops, didn't want to do that. Although these look very similar, they're going to give you very different answers once you substitute those values in. And some last little things with mathematical operations is if you had a plus, sorry, not a plus, if you had a minus and a minus, this actually just becomes a plus. So if you ever see two numbers minus together like that, so if it was like 3 minus -2, this will actually become 3.
Cat on my tree. Is it a cat? What is that? Cat. I don't know. What the hell is that? Hey, a cat possum. So weird.
Plus 2. Okay, so that's always a good one to keep in mind. And the last thing, which I probably haven't mentioned, I probably could have mentioned plus 2. So if you ever see two numbers minus together like that, so if it was like 3 minus -2, this will actually become 3 plus 2. Okay, so that's always a good one to keep in mind. And the last thing, which I probably haven't mentioned, I probably could have mentioned in the basic operations, but that's brackets. So brackets basically just mean that there's a term inside, and whatever's inside needs to be done first. So if we had x plus 1, 2, well, this 2 could be on the other side as well. It basically means that with that bracket, you can just interpret as a multiply. So there's like an invisible multiply in here. But what it's saying is, this is kind of the example that I was choosing before with the complex one, is this 2 is multiplied by x plus 1, okay? So this is an example where we need to add 1 to x first before we multiply it by 2. So that's just, but you could do a number of different things here. So you could divide that by 2 to cancel that 2 out, or you could do something called expanding the brackets. So as it's 2 times x plus 1, we can actually just expand that out if we multiply, because it's 2, a plus, sorry, not a plus. If you had a minus and a minus, this actually just becomes a plus. So if you ever see two numbers minus together like that, so if it was like 3 minus -2, this will actually become 3 plus 2. Okay, so that's always a good one to keep in mind. And the last thing, which I bracket, you can just interpret as a complex one. We need to add 1 to x first before we multiply it by 2. So that's just, but you could do a number of different things here. So you could divide that by 2 to cancel that 2 out, or you could do something called expanding the brackets. So as it's 2 times x plus 1, we can actually just expand that out if we multiply, because it's 2 times x plus 1. So if we multiply each of those terms by 2, then that's actually what we've just expanded it out. So this would be 2x plus 2. Okay, and that kind of makes sense because we'll have two groups, because that's what a multiply is, two groups of x plus 1. So that will mean we'll have x as it's 2 times. Okay? So this is an example where we need to add 1 to x first before we multiply it by 2. So that's just, but you could do a number of different things here. So you could divide that by 2 to cancel that 2 out, or you could do something called expanding the brackets. So as it's 2 times x plus 1, we can actually just expand that out if we multiply, because it's 2 times x plus 1. So if we multiply each of those terms by 2, then that's actually what we've just expanded it out. So this would be 2x plus 2. Okay, and that kind of makes sense because we'll have two groups, because that's what a multiply is, two groups of x plus 1. So that will mean we'll have x plus 1 and x plus 1. So therefore, we've got two x's plus 2.
How do you do negatives on the calculator?
Okay, and the last, because it's 2 times x plus 1, we can actually just expand that out if we multiply, because it's 2 times x plus 1. So if we multiply each of those terms by 2, then that's actually what we've just expanded it out. So this would be 2x plus 2. Okay, and that kind of makes sense because we'll have two groups, because that's what a multiply is, two groups of x plus 1. So that will mean we'll have x plus 1 and x plus 1. So therefore we've got 2x's plus 2. Okay, so we're going to continue on this.
Okay, I haven't got much time left, so I'll just jump into some questions, I guess. And then maybe organize what exam I'm gonna do. Maybe maybe we do. Maybe we finish these all these tutorials, and then we do this guy's test. Okay, I'm doing gonna skip question 8 and 10 because I kind of remember that. Gonna do. Okay, we'll do question 11 to 13. 11 to 13 on practice test A, the pink one. Table was the formula of the R group for some carboxylic acids, general formula R. The value of property H for carboxylic acid is shown. Question 11. Which of the following is the best estimate of the value of H for 2-chloropentanoic acid? Best estimate of the value of H. Property H. I don't know what H is, but doesn't matter. Formulation of the R groups. Okay, the R groups. Carboxylic acids of general formula R, carboxylic acid group. So, which of the following is the best estimate of the value of H for 2-chloropentanoic acid? Okay, 2-chloropentanoic acid. Pentanoic acid. so I have chloroethanoic acid, chloroethanoic acid, I wish I had a sharpener, acid, which equals 45.6, 45.6. So that's my chloro. Don't have a pentanoic. Pentanoic. Ethanoic, but I have an ethanoic. Ethanoic. That equals 67.7. So the difference is difference is 17.1. So minus 17.1 and plus 17. I have a 2-chloropropanoic acid. 2-chloropropanoic. Forty-five point two. 45.2. Propanoic acid. 8.8. Difference of 18.8. 18.3. No. 18. 3. 23.3. Propanoic acid minus 23.3. Propanoic plus 23.3. And then a 3. We have a 3-chloropanoic acid. Wait, let's go. We have a 3-chloropropanoic. 60. That is minus. No, sorry. Plus 14. I haven't really defined the question. That's why I'm just freestyling this. I don't really define the question until I know a bit of the pattern here. So the following is the best estimate of H2 chloropentanoic acid. Yeah, I really don't know how to define the question here is the main problem. I'm kind of just searching out a pattern and I can't find it. And I feel like I'm missing a bit of prereq knowledge to answer the question. I want to guess A, 46.1, because 2-chloropropanoic acid is 45.2. 2-chlorobutanoic acid is 45.6. So, chlorobutanoic acid. 3 acid is 60.7. Chloroethanoic acid is 45.6. I don't know. Maybe we watch the. I'll just try and figure it out myself. I'll get it up just in case. but I'll have a crack at it myself.
8. Okay, so I have seen this question before, but I can't remember the answers, which is good. So I also seem to remember struggling with this one, so that's not good for me. Okay, from hypothesis 1, it can be concluded that the 11 to 13. So,
We'll leave. I actually have to run, but um, I'll come back and finish off that question either this afternoon or tomorrow, probably tomorrow morning, same time. So if you want to join the live session or join the Discord or all that cool stuff, feel free. Feel free. Um, yeah, join the Discord. Um, Grab on the Twitch so you get notifications and you can like watch the live study and like join in study at the same time, do the same things I'm doing, or um, tell me what you're doing and maybe I could do some of that if it's helpful. Yeah, anyway, so see you all in the next one.